Hello guys, today we will discuss several factorization techniques starting from the very beginner ones to the very advanced ones, and in the end of the video we will discuss several applications from the Olympiads. The first one and the most well known is difference of squares. A square minus b square can be factorized as a minus b times a plus b. And now let's see why it is correct. If we expand this by term, we will get a square minus uh, plus ab minus ab minus b square. And clearly, middle term cancel out each other, and we are left only a square minus b square. Second, the most well known is difference of cubes. A cube minus b cube can be written as a minus b times a square plus ab plus b square. If we expand this one once again, we will get a cube plus a square b plus ab squared minus ba squared minus 8b squared minus b cubed. And clearly we will see that these terms cross out each other and we are left only first term minus last term, which is exactly a cube minus b cube. Similarly, if we use the same technique for the sum of the cubes, a cube plus b cube can be represented as a plus b times a square minus ab plus b square. Once again, if we expand, we will get a cube minus a squared b plus ab squared plus ba squared minus ab squared plus b cubed. We can see that we have minus a squared b here, but plus mark also. So they cross out each other, and similarly, ab squared and plus ab squared and minus ab squared cross out each other. So we are left a cube plus b cube. Unfortunately, a squared plus b squared cannot be factorized so well, but sometimes this one is written as a plus b squared minus 2 times ab. And see why it is correct, because this one expands as a squared plus b squared plus 2ab, and if we take minus 2ab, we will get exactly what we want. Now let's prove a bit generalized versions. For example, if we are given a to the power of n minus b to the power of n, this one can be written as a minus b times a to the power of n minus 1 plus a to the n minus 2 times b, a to the n minus 3 times b squared, and so on. Last term will be b to the power of n minus 1. And see why it is correct, because if we expand, we will get a to the n plus a to the n minus 1 times b plus a to the n minus 2 times b squared, and keep going like this until we reach the last term, which will be a times b to the n minus 1. And all the remaining terms will be negative marks, and they will be b times a to the n minus 1 minus b times b squared times a to the n minus 2, and so on. And final minus term will be minus b to the power of n. And here we can see that these middle terms will be same, and last term will be left and only first one. So this one can be rewritten as a to the power of n minus b to the power of n. And we proved our equation. A to the power of n plus b to the power of n cannot be factorized always. This factorizes if and only if n is odd number. And this one is a plus b times a to the n minus 1 times minus a to the n minus 2 times b, then plus a to the n minus 3 times b squared, and so on. Here we have pluses and minuses alternating, and final one will be b to the power of n minus 1, because, as I already said, n is odd number, and last term must be positive. And if we expand this one once again, we will get a to the power of n minus a to the n minus 1 times b plus a to the n minus 2 times b squared, and so on. Last term will be plus a times b to the n minus 1, and start the terms which can be grouped with b. So this will be plus b times a to the n minus 1, which clearly cross out second term in the expansion. Then next one will be minus a to the n minus 2 times b squared. Clearly, this one also crosses out this one, and so on. The only terms which will be left will be last term and first term, which is exactly a to the power of n plus b to the power of n. And we are done. Now we will see the examples how to use them. My first example, if we are given this kind of sum, 1 divided by 1 plus root 2 plus 1 divided by root 2 plus root 3 plus 1 divided by root 3 plus root 4 and so on until 1 plus root 2024 plus root 2025. Here the idea is that 1 divided by root a plus root b can be represented as root a minus root b divided by root a plus root b times root a minus root b. And clearly, this one can be rewritten as root a minus root b divided by a minus b if we use the difference of square factorization method. In our case, 1 divided by 1 plus root 2 can be written as root 2 minus 1 divided by 2 minus 1, which is exactly root 2 minus 1. Similarly, second term, 1 divided by root 2 plus root 3 can be written as root 3 minus root 2 divided by 3 minus 2, which is exactly root 3 minus root 2. And if we apply the same technique for every term, our sum can be rewritten as root 2 minus 1 plus root 3 minus root 2 plus root 4 minus root 3 and so on. Last term will be plus root 2025 minus root 2024. And we can easily see that most of the terms will be cancelled except the first negative term and last positive term, because root 2 part cancels here, root 3 part cancels here, and so on. So this number will be rewritten as root 2025 minus root 1, 1, just 1, which is exactly 45 minus 1, because 2025 is perfect square, and answer will be 44. While this number is not so intuitive because this is product of fractions, we have in the denominators, we have square roots. Sometimes this kind of root sums exist, and this technique is called telescopic sum. Next example is almost similar, but we are using here a difference of cube formula. For example, if we are given 1 divided by cubic root 1 plus cubic root 2 plus cubic root 4 plus same thing, if you write here cubic root 4 plus cubic root 6 plus cubic root 9 and so on until we reach 1 divided by cubic root 100 squared plus cubic root 100 times 101 plus cubic root 101 squared. In this problem, we will use the factorization of 1 over a squared plus ab plus b squared can be written as b minus a divided by b minus a times a squared plus ab plus b squared, which is exactly factorization. This is the factorization of b cubed minus a cubed. So our sum will be b minus a divided by b cubed minus a cubed. And in our case, in the first fraction, in terms of a, we have cubic root 1, and in terms of b, we have cubic root 2, because cubic root 2 squared is cubic root 4. So if we apply our formula for the first fraction, this one can be rewritten as like Yes. Cubic root 2 minus cubic root 1 divided by 2 minus 1, which is exactly cubic root 2 minus cubic root 1. Clearly, if you do the same operation for the second fraction, this one will be rewritten as cubic root 3 minus cubic root 2. And if you keep going like this, and we use the same idea as it was in the previous example, all of the terms will be crossed out, and we are left only the first term and first negative term and last positive term, which clearly will be cubic root 101 minus cubic root 1, which is exactly 1. This kind of telescopic sum formula is very important even for the international level Olympiads. So this is the last example of today's video, which is from Stanford Math Tournament 2024. Here we need to compute this sum. Today I will not solve the whole question. You can try this at home. I'll just give you a small hint. The idea in this question is to group the numbers like this. If we take 2 times 4 minus 3 times 1, their difference equals to 5. Similarly, if we take 3 times 5 minus 2 times 4, their difference equals to 7. And from here comes the intuition that if you consider 1 over 1 times 3 minus 1 over 2 times 4, this one simplifies as 1 times 2 times 4 minus 1 times 3 divided by 1 times 2 times 3 times 4, if we take the common denominator. And numerator will be clearly 5, which was exactly our numerator here. And clearly denominator stays same. If we do the same operation for the second one, and if we take 1 divided by 2 times 4 minus 1 divided by 3 times 5, this one simplifies as 1 times 3 times 5 minus 1 times 2 times 4 divided by 2 times 3 times 4 times 5, which is clearly 7 divided by 2 times 3 times 4 times 5. Try to use this technique to compute the whole sum and somehow make up this telescopic series. If you will be interested about this question, please write in the comments and I will record another video about this.